Okay, video 3, page 3. Starting with number 22. Solve each radical equation. So on this one, we can square both sides. And that should give us 3 minus b is equal to 2b. We need to get all the b's to one side, so let's add b to both sides. 3 is equal to 3b. Divide both sides by 3. b is equal to 1. This one here, square both sides, and we end up getting 7 minus 2n is equal to 6n minus 1. So we're squaring both sides. We will add 2n to both sides to cancel that out. And we will add 1 both sides to cancel this side out. That way we have all our constants on one side, all our variables on the other. So 7 plus 1 is 8. 6n plus 2n is 8n. And this ends up being n is equal to 1 again, after, once again, we divide both sides by 8. Okay, on this side, the square root of 2x plus 3, so we're going to square both sides, and we get 2x plus 3 is equal to 1, and this is just now an algebra problem. Minus 3 to both sides, 2x equals negative 2, divided by 2. X is equal to negative 1. Done. Okay, exponential functions. F of x equals 3 times 2 to the x minus 1. So we need to sketch the graph, identify the domain, range, asymptote, and end behavior, and whether the graph is representing growth or decay. So let's start with graphing it. I'll have x over here and f of x over there. Let's start with something like if I plug in 0. So plug in 0, 2 to the 0 is 1. 3 times 1, remember order of operations, so 3 times 1 is 3, minus 1 is 2. So 0, 2 is a number that we're going to use. Let's plug in 1. 2 to the first power is 2. 3 times 2 is 6. 6 minus 1 is 5. So this is 2, 4, 6, 8. I'm trying to read these numbers here. Okay. So now we have, let's plug in 2. So 2 times 2 is 4. 3 times that is 12. 12 minus 1 is 11. Might be able to get one more. 3 squared is 9. 9 times 3 is 27. Nope, no way we can do that. So that's going to be 2 pi. That's going to be way off our graph. So we have 0, 2. We have 1, 5. And 2, 11. Right there. Let's get some lower numbers too. So let's go with negative 1. So negative 1 would be 1/2. 3 times 1/2 is 3 halves. And then 3 halves minus 1 would be 1/2 again. So negative 1 and 1/2. So then we have 1, negative 1. Let's go with negative 2. So that would be 1/4. 3 times 1/4 is 3/4 minus 1. So 3/4 minus 4/4 is a negative 1/4. So we have a negative 1 and 1/2. We have a negative 2 and negative 1/4. So right about there. And it's just going to get approach the asymptote from there. So we sketch our graph. Just like that. So our domain, we can use our domain for all exponential functions is all real numbers. We can use all real numbers. The range for our real function is the lowest number we can use in this case is our asymptote, which is negative 1. Now, we can't actually ever reach negative 1, so this is going to be open. And then it will go all the way up to positive infinity. Our asymptote is going to be this line right here. And it's a line, and it's horizontal, so it's going to be y equals negative 1. In behavior, so as x approaches the small side of the domain, which is negative infinity, y is approaching, well, it's going down, it's decreasing, going in that direction towards the asymptote, so it's approaching negative 1. It's approaching the lower side of its domain. And then as x approaches the upper side of its domain, so positive infinity, y is shooting up in the air really quickly, so y is approaching positive infinity. And as you can see, reading left to right, it is increasing, so this is definitely growth. Definitely growth. Okay. So do the same process for this next one here. So here we're going to have x and f of x. And again, you can always type this in your calculator and get the table from there as well. So what we're going to start with here is we're going to start with, let's start with 0. Why not? And 1/2 to the 0th power is 1. Anything to the 0th power is 1. 3 times 1 is 3. 3 minus 2 is 1. Plug in 1. Well, that's 1/2 to the first power is 1/2. So that's going to be 3/2. 3/2 minus 2, so 2 is 4/2. So you get 3/2 minus 4/2 is a negative 1/2. And then at 2, voice squeak there, did you hear that? Puberty. 2 1/2 squared is 1/4. 3 times 1/4 is 3/4. And we're going to subtract 8/4 to make sure, so 3 to get common denominators. So 3/4 minus 8/4 is a negative 5/4. Now I know it's hard to graph fractions, so in this particular case, you can actually just say, okay, that's negative 0.5. So no, that's going to be halfway. This is negative 1.25. So you can put these to fractions to graph, or to decimals. I know I like fractions better, but it is so much easier to graph decimals. This is going to keep getting smaller and smaller. So if we do a 3, it's the last one we'll do for this direction, is that's going to be 1/8 times 3 is 3/8. And so that's going to be 16/8 to make sure it's a 2. So 3/8 minus 16/8 is a negative 13/8, which I actually didn't bring a calculator home with me. I don't have one here. So that is 5/8. So that's going to be 5/625. So it should be negative 1.625, I believe. And it's going to keep getting closer to -2 because -2 is our asymptote. We can actually write that down there. Asymptote is y equal to -2. So that gives us this direction. We have 0 and 1. So 0 and 1. I have 1 and 1, -1/2. And then we go just below there, and then it's going to keep getting smaller and smaller and smaller and approaching that right there. But what happens over here on this end? So let's start plugging in some negative numbers. At -1, this fraction flips and becomes a 2. So 3 times 2 is 6, minus 2 is 4. At -2, so that the negative flips the fraction to be 2, so this becomes 2 to the second power, so that's 4. 3 times 4 is 12. 12 minus 2 is 10. Okay, let's do one more. -3. It flips it, so this is going to be 2 to the third power. The negative will flip that fraction again. So 2 to the third power is 8. 3 times 8 is 24. Minus 2 is 22. That's off our graph. We can't really graph that. So let's grab these real quick. So that's going to be -1 and +4. And then we have -2 and 10. Too far. Right here. And then it's going to go up real quick. It'll be off the graph before it gets to -3. So there we go. There is our graph. Our domain is still, as with all exponentials, all real numbers for our domain. Our range, well, the lowest point is our asymptote at -2, which is going to be open because you can't actually reach our asymptote. And it goes all the way up to positive infinity. And then as x approaches the small side of its domain towards -infinity, y approaches, well, approaching this direction, y is shooting up, so y is actually going to positive infinity this time. And as x approaches the upper side of its domain, positive infinity, y will always keep getting closer to -2, but never actually reach it, so y is approaching -2. Okay, this last section on here, identify which logarithm property was used. So looking at this, log to the log base 4, 2.1 is equal to the natural log of 2.1 divided by the natural log of 4. So what's happened here is we changed the base from 4 to e, to the natural log. So this is the change of base. Change of base property. The natural log of 3 plus the natural log of 5 is equal to the natural log of 15. So this is the sum of logs. We've taken that sum and we've multiplied them together. Logs take addition, logs take multiplication and turn it to addition and vice versa. Log base 4x squared is equal to 2 log 4. So what happened here is that this power got moved to become the coefficient. So this ends up being the, I believe it's called the exponential property. The the exponential property. Okay, that's it for this video. I'll see you guys in the next one.